All right, in this video, we are going to use a matrix to find a quadratic function. All right, let me show you how we're going to do that. So if we've been given these 3 points and we know that they are part of a parabola, what we want to find is the equation for that parabola. So here's what we do know, right? We know that the equation for any given parabola can be written in standard form just like this, right? And so if I take each of the individual points and plug them in, for example, xy, I know that xy is 0, 5, so I can go through and plug in a 0 here and here. I can plug in a 5 right there. So I'm going to have 5 equals a times 0 squared plus b times 0 plus c. And then if I go continue to do that for the rest of them, plug in the x and y for the 2 and 13, and then plug in the xy for the 3 and the 26, we're going to get the following equations. We get 13 equals a times 2 squared plus b times 2 plus c, and then I have 26 equals a times 3 squared plus b times 3 plus c. So then if I go simplify just a little bit, for example, 0 squared is just 0, so what you get is 0a plus 0b plus c equals 5. Then I have 4a plus 2b plus c equals 13. And we have 9a plus 3b plus c equals 26. And now when we write it like this, we can see that I have 3 equations, all with 3 variables apiece, which just simply becomes a 3 by 3 system. Now, if I take these constants and coefficients and turn them into a matrix, I will get the matrix 0, 0, 1, right? Because the coefficient in front of C is 1, coefficient in front of A is 0, coefficient in front of B is 0, right? And then that equals, on the other side, is 5, right? So doing the same thing with the rest of them, 4, 2, 1, 13. Then I got 9, 3, 1, and 26. Okay, so now I have this augmented matrix that I can now perform row operations on. And what we're looking for here is what's called row reduced echelon form, right? So in other words, I want to do a series of row operations that turns it into the identity matrix over here on the left. Okay, and then I'm going to get a very specific number over here, right? So as we do all of our row operations here, these numbers end up changing, right? And so at the end, we're going to be left with this is A, this is B, this is C. Now, you can do this by hand, no doubt, okay, by performing row operations of switch any 2 rows, multiply a row by a constant that's not 0, or I can add rows together, all right? Or we've learned now at this point, you can use a calculator to do this, right? So let's switch over to a calculator. Now, as you can see, I've already put that matrix into our Desmos matrix calculator, right? I have my augmented matrix. Now, the idea, again, is to get the identity matrix on the 3 by 3 side to the left. And again, we call that row reduced echelon form. So I'm going to tap the RREF button, and then I'm going to tell my matrix calculator to use matrix A. And I can close parentheses if I want, but now you can see here we get the following matrix. We get the identity matrix on the left, and then we get 3, negative 2, and 5. So let's switch back to our worksheet. All right, so now once I get that row reduced echelon form, I can erase these, and now we can remember that it was a 3, negative 2, and a 5. So I can do my row operations by hand, or I can have the calculator do that for me. Now, what this tells me is that is A, B, and C. And if I go plug it back into my original equation of y equals ax squared plus bx plus c, my function now ends up being 3x squared minus 2x plus 5. So this equation is going to contain the 3 points from earlier in our problem. Okay, so real quick, we're going to use the 3 points, plug them into standard form to get a 3 by 3 system of equations, 3 variables, 3 equations. I'm going to turn that into an augmented matrix. Then I'm going to find the RREF of that matrix. And when I do, that means the identity matrix is here. And then the numbers over on the right side will be my A, B, and C values, which I then plug back into the original standard form to get our final answer here. Okay, I hope this video helps, and we'll see you in the next one.